Tonight's topic, the CBD meeting, is glazing, recent amendments and energy efficiency. Can I ask you first to make sure you turn your phones off? Thank you. There's an assessment form that you should have been given as you came in. Could you please fill it out as we go? And then when we complete, if you take it to the back table, you'll be given your CBD receipt. There's also publications that have kindly been provided by Noel, which you can also get as you go out. So I'd like to introduce you to Noel Stokes. Noel's the Manager Industry and Government with Veridian, which was Pilkington's. Noel is also on the technical committee of AWA, the Australian Window Association, and AGA, the Australian Glazing Association. If I could ask you to welcome Noel, thank you very much.
Thanks, Alan. Alan and I are going to try and perform a trick here tonight that I'm going to talk and he's going to advance the slides, and with a little bit of luck we'll get it together, hopefully. Alan mentioned in the introduction that I'm on a couple of committees, and one of those is or two of them, the Glass and Glazing Association and the Australian Window Association, as such representing them on the standards committees. And standards committees are something you go on to if you desperately need to go and get a life, or if you go on one you certainly need to get one because it's painful. We went through the glass standard, and rewriting it only took 10 years, and I think there was more done in the last 3 months than there was leading up to that. But when you go into the makeup of these bodies and you're supposed to get agreement, and there's so many conflicting views, it's not easy. And as time goes by, it's getting harder and harder. You know, one of the big influences on all of these committees these days is the Australian Building Codes Board, and they in turn have a lot of rules that they have to comply with. And some of us tend to say that they're a nonsense and we have to get on with things, but it doesn't work quite that way. What I'm going to try and do over the next 40 minutes or so is cover the two topics, the standards and energy efficiency. Now, for starters, I can tell you that's an absolute impossibility, and all I'll be doing is skimming across the surface. But again, as Alan mentioned, I have brought a publication with me, and there's a copy there for each of you, which is this one, the Architectural Glass Specifiers Guide. Without a doubt, it'll be the best publication our company's ever produced, and if there's anything you want to know about glass, whether it be relating to standards or to energy, you'll find it in there. And it's probably the most clear and easy to understand publication that we've ever had, I'm sure of that. Now, I was introduced as being with Veridian. Well, I'm sure you'd never heard of Veridian before tonight or before you knew I was coming, but what we've been through, I've been with the company quite a lot of years, but I was with Pilkington, and Pilkington were established in Australia probably 30 years ago, and that came about by taking over a number of other smaller companies in Australia, and have operated as Pilkington Australasia for that 30 or so years. However, it's caught up, and Pilkington Australasia was taken over by CSR recently, and for most of us I think it's a good move. I often think whenever you looked at the annual report of Pilkington, we, along with Argentina, justified the last paragraph on the last page. So we're a pretty small part of a major international organisation, but now we're actually a very major part of an Australian-owned organisation, and I think most of us feel pretty comfortable about that. The organisation of Veridian was formed after that takeover by two companies coming on board, Pilkington Australasia and the other is DMS, who you may have heard of, better known in Victoria, but they certainly do a lot in New South Wales. And between Pilkington, DMS, and you could throw in G. James, who are not part of that. That's the three big players in the glass industry in Australia. So I guess there's now two big players. So Pilkington and DMS now equals Veridian. The agenda that I'm going to go through, I'll start talking about AS 1288 2006. I'll just touch on some of the recent amendments and where that's going. I'll then go on in the other half to talk a little bit about energy efficient glazing, and I'll just try to pick up enough that I hope I can generate a bit of interest, and you might even go away and sit up in bed tonight and read that book that I'll leave you. Firstly, AS 1288 2006 was referenced in the BCA in May 2006 and again in May 2007. It superseded the book or the standard that had been in place since 1994, which was well and truly out of date. There's already been an amendment to that document, which was published in January of this year. There's a second amendment, and I'll talk a little bit more about that shortly, which is due to be published hopefully by September this year, which means it gets referenced in the building code in May of next year. And already there's a little bit of work being done on amendment number 3. Why can't they make up their mind, you might ask? But it's interesting where these things come from. And one of the key problems I've found with standards, and it's just the way it works, but a standard is written, and as part of the process it has to get a draft is prepared that goes out for public comment before a committee votes on it. And surprisingly, you don't get many comments, and that's where the system fails. Because, and most of us that sit on the committee, you know, we're full of theory and not too much practice in recent years. And so we get the good comments coming back when people that do have to actually put it into place start using it. And they find the faults and the flaws and the defects in it and start raising questions. And as you find out about those, of course, you just have to fix them up. And it's doing functions like this that I've certainly picked up a lot, and I'd be responsible for more amendments on the standard than anyone else, pure and simply because of these sort of functions. When guys come up to me afterwards or in a question time, they'll say, why on earth did you do that? And they've got a good reason, and we can put through an amendment. There's an additional publication I'll touch on, which Alan might be able to bring up on the screen, called the Glazing Handbook, and that was written at the same time as the standard. And the reason for that was that when the standard was published, it was seen as being so different to what was there before, particularly in the areas of wind loading, of balustrades, overhead glazing, that it was felt there was a need to have an additional publication to explain what it was all about. So there's about half of this book is devoted to AS 1288, and it does have a lot of examples in it. Now, most of you, I understand, are builders, and perhaps many of those examples you wouldn't have to follow them through, because I guess you'd never have to work out the thickness of glass to suit the wind load. But there's a lot of other parts there, such as human impact and balustrades and so on, that I think you might find interesting, and at least it's written in everyday English, unlike standards which are written in some other form of English that is quite difficult to follow through. So if you look at the list of subjects that are in that standard there, as I said, the first half of it is devoted to AS 1288, and I guess it's your easy to read version of 1288. And the rest, and after you've written a book of 70 pages or so, you figure, well, to make it worthwhile, it's not going to cost much more to put some other subjects in. So we've tried to pick out the topics that are pretty current at the present time. And obviously the big one these days is energy efficiency. And that's come a long way, and I'll talk about that in the second half of this presentation. But some of the subjects there really took a lot of work. If you look at one which surprised me, glass in fences for swimming pools, I thought that's pretty easy. But when you start on it, it's the most complicated subject you could ever find. And I remember having to research it and found that hardly any state uses the building code. They all have their own versions, and at different levels of government, where those regulations have been applied. So swimming pool fences, despite the importance of them, is probably the greatest mess of any document that I've had any dealings with. So I'll just go quickly down what AS 1288 is made up of, and a lot of it, as I said, probably isn't critical to you people, but the scope and general materials wouldn't worry you. The general requirements of a standard are there for one reason. It's the basis of the rest of the document. If you can't use the stuff that's written in the standard, which is the deemed to comply part, you can go back to section 3, and that's the basis of all of the tables, all of the charts, all of the formula. They're all based on that. And that was, so if you go to an engineer and he has to do something unusual, that's the part of the standard that you would go to. But with the exception of a couple of clauses, really you leave that alone. It's strictly for engineers, and beyond us ordinary mortals. Human safety impact requirements, of course, is probably the part that is most critical to all, and as time goes by it never ceases to amaze me how often this is ignored and how often cases wind up in court over accidents and just pure and simply through non-compliance. And I would hope you've never had the experience of going to court but over something like glass injury, but it's quite horrendous. But one thing I can tell you is that the experience of myself and others who have been required to appear, well, it's not always consistent. Judges tend to toss out the building code first of all, and they will tend to go to a standard as the preferred document. So compliance with that standard is essential. I might add, however, that some judges toss out the standards as well and just talk about duty of care and a product being fit for purpose. But duty of care is probably the most important part, and that's really tied up with which documents you comply with in any case. Sloped overhead glazing is quite critical now. There was a lot of changes made in this version of the standard, and it had to be updated. There's some limitations now on the type of glass that can be used, and that again is as a result of accidents over the years with glass breakage. Balustrades is probably the most unfortunate section in this standard. In the previous standard, there were, I think, 2 paragraphs written on glass balustrades. This time there's a whole section that runs to about 7 or 8 pages, and having written that, we find that most can't understand it in any way. So what's happening now is that that section is being entirely rewritten and is expected to be the main part of the second revision. So they're the overview of it, and of course all of this standard is described as as normative, which means it all has to be complied with. If we went into the appendix, which is, it's all informative, so you could say you don't have to comply with anything that's in the appendix, it's there as additional information. So the main parts of that, however, are the section 4 about wind loading and the one on sloped overhead glazing, I would suggest, are probably the most important. Just a few of the changes that have occurred following the introduction of the 2006 standard and the revision this year. One that had to be clarified was to do with wardrobe doors. And this came about because for a long time we'd all accepted that you can have a glass or a mirrored sliding door that goes into a wardrobe. And then it turned out there was a few injuries relating to these, and building inspectors were pulling some builders up because the usage was being changed, and builders were putting them into, say, a doorway between a bedroom and a bathroom, or a bedroom and an ensuite, or a walk-through wardrobe, and then arguing that it's not a door. And you can imagine the sort of arguments that came about that. It was always required that as a door, of course, it has to be grade A. And I know in our case, in our company, we tested our product, and I guess you're all familiar with the sort of product that has that white vinyl on the inside of a wardrobe door. We found that you put the grade A test to it and it failed miserably, and that really explained why people had been injured. So we certainly had to search the world to find another product to match up, but there's still some products out there today that really don't pass the test. And when you think about a wardrobe door in a light, very, very light aluminium frame with a piece of 4mm mirror there, it doesn't take much to imagine what can happen, and certainly it has happened. But to clear up the confusion, we had to put a definition in. This definition was finally written by a fellow from the Building Codes Board, actually, that said that doors that provide access to built-in storage areas, excluding those fitted to a piece of furniture that are not built into the building. Doors providing access to walk-in wardrobes are defined as doors. And as such, it means they just have to be a grade A safety product. The variations to that: wardrobe doors with mirrors defined, where the mirror is not completely adhered to a solid backing, shall be grade A. However, it does provide that, in fact, what that clause is saying is if you don't have that grade A vinyl, you can apply it to another material, but it has to have complete adhesion to it so that if it breaks, you don't have loose pieces of glass. I've left the bottom clause there. Doors in bathrooms, en-suites and spa rooms have to be in accordance with a separate clause. And one of the unfortunate parts about it is that probably the most dangerous part in any house, I guess, is the wet areas and particularly the bathroom. Yet if you were to look at the tables for glass, they're generally less in bathrooms than they are in other rooms. And that's a classic case of where commercial pressures have been brought to bear, and that if you didn't buckle in the end, the standard would never be finished. Unframed doors, they're not so bad, generally have to be 10mm and they have to be laminated or laminated toughened, but of course you can get a partly framed shower door in 5mm toughened glass, and I guess you've installed them and you know how those things move around when they get pretty high, because they can be as high as 3 metres, I've seen them. That slide there, which refers to glass in bathrooms being grade A or grade B, and I've left that there just to highlight the fact that you can use grade B safety glass in a bathroom, and it's about the only place you can use a grade B glass. And the only grade B glass is wired glass, which generally speaking has gone out of fashion, and you would think there's not a lot of it made today, but in fact there's an awful lot of it still being made. For some reason, a big percentage of it goes to Western Australia, and we've never quite worked out why that is, but nevertheless it does. And there's a process going on at the moment to rewrite all the tests for safety glass, and one of the proposals is that wired glass be removed as a safety glass. I'm certainly aware of accidents that have occurred over the years involving safety glass. You'd have to say wired glass is not a safety glass. There was one I remember in Brisbane where there was a fellow at home on his own inside a wired glass shower, and he slipped and fell, threw out his arm, it broke the glass, his arm went through, and the wire did what it's supposed to do, and that's hold the glass in one piece. The problem he had was that he couldn't get his arm out, the wire gripped it, and he bled to death in the shower. So if a product can do that, I think it's fair enough that we've got to face up to it not being a grade A safety glass. So when it comes to bathrooms, and we're often asked, well, how do you decide what is the appropriate product and how thick and so on? And it's really quite simple, and there's not much, well, there is no science to it, I should add. And there's that one table that's in the standard, table 5.1, and it lays down the various types of glass. The two top ones are grade A, toughened and toughened laminated, and the bottom one is just laminated. And the third one down, safety organic coated mirror or vinyl back. They're the three that can be used in those applications, and because wind pressure obviously doesn't come into it, it's simply a case of what's the area of the glass and how thick does it need to be. So that's pretty straightforward. And the final one, a little bit like wardrobe, is that you can use ordinary annealed, or have been able to use ordinary annealed mirror, provided it was completely and solidly adhered to a wall or a cupboard door or whatever, but it had to be fixed such that if it breaks, you don't get loose fragments of glass. One amendment that went through in these amendments last year was that ordinary annealed glass, including mirrors, can be used provided a fixed vanity or bench having a height of not less than 760, a depth of not less than 300, that extends the full width of the glass or mirror is located in front of the glass or mirror. And it's a pretty obvious one. That's a classic case of where nobody thought of it, I suppose. I really don't know why. But you can't do too much damage to a mirror when it's protected by a vanity. I did show you that table before that applied to bathrooms, but again this harks back to what I said about there's greater laxity in the glass requirements in bathrooms than anywhere else. And this table applies to the maximum areas of toughened glass or laminated toughened that can be used in frameless shower screen doors. And as you can see, you can get up to 3 square metres in 6mm glass. So you can do that there, but you couldn't do it in any other sort of door. External shop fronts was also an amendment, and it's another one of those curiosities that in the 1994 standard, shop fronts were difficult to read. You actually had to look at about, I think it was 5 different parts of the standard before you could be sure you'd picked up how the thing should be glazed. So we tried to tidy that up, and I think we did that fairly well. But then inevitably some people were starting to put or interpreting other areas as shop fronts when they really weren't shop fronts. And one classic, which I still don't understand, it was if you can imagine one of those typical light industrial buildings that has some maybe office or showroom at the front, you know, a bit of shop front aluminium there, and Besser block walls down the back and side, and it probably has windows in the back and side. And some were arguing that those windows had to be glazed as shop front. Well, that was never the intent at all and didn't make sense. So we battled away again in conjunction with the Building Codes Board to put in a definition, and now a shop front simply means it's the glazed or partly glazed wall at public access level in shopping malls, arcades and similar public areas of non-residential buildings, with or without a stall board, suitable or intended, or both, for the display of products or services. So it was a case of you kept tacking on words trying to cover all of these possibilities. But it was really meant to be the sort of situation where people stand against the glass looking through it and where accidents have been known to happen. One of the important things in reading the glass standard is, and I think we're picking it up at the present time, is that people read what's required for an external shop front, or what's required for an internal shop front, or what's required for some other application. But in all cases, you have to consider firstly, and shop fronts are a good example, you consider how you're supposed to glaze a shop front, but first and foremost, you've got to consider, is there a door in it? And if there is, you glaze the door to the requirements for a door. If there's a side panel, you glaze that to the requirements for a side panel. If it's capable of being mistaken for an opening by somebody not made aware of the presence of glass, again, you glaze it to that part of the standard. And then it's a case of what's left over is what you glaze to the shop front clause. And you know, when you think of typical shop fronts, it doesn't leave very much, and it's really only when you get a long run of shop front that shop front clause starts to apply. A further recent change was to bring the glass standard in line with the building code. We had a clause there covering schools, early childhood centres, aged care buildings, retirement villages and nursing homes, and the reference to retirement villages has been taken out. During the course of writing the standard, we wrote this one to be consistent with the building code, but the building code changed, but we didn't keep up with it. And my understanding is that the Building Codes Board are having some difficulty with retirement villages and retirement homes. There's a lot of words get used, nursing homes, retirement villages, aged care homes and so on, but it's pretty grey where one ends and the other starts. I mean, you don't have to go drive around and see the ads for retirement home for 50-year-olds now, so you know, they mean different things. But nevertheless, it was felt best to make it consistent with the building code. So again, when we look at any of those buildings, we've got to glaze the doors and the side panels and other panels in accordance with the appropriate clauses. But then anything else we glaze to these clauses. So the first one's childhood centres. The code previously called them Childcare Centres, and that was changed. And that was largely because you'd have probably been aware of that accident that occurred in Sydney area. Some must be getting up to 3 or 4 years ago now, where a young boy went through glass in a home where he'd been left all day, and his mother has been on most of the television programs being very critical because that particular house, which came under a particular heading, was one that didn't have any regulations covering it. Yet if it was a childhood centre, there were an awful lot of regulations covering it, and most people are not aware of that. So from our point of view, we felt it was necessary to be consistent with the building code, and that requires that all glass within a metre of the floor must be safety glass. So again, you glaze the doors properly, the side panels, and it's whatever other windows or other panels are there must be glazed to within a metre of the floor in safety glass. And in that type of building where it talks about schools, we're talking about primary and secondary only. With the aged care buildings and nursing homes, the same rules apply. The difference is it's 1500 from the floor. And a lot of people have said, well, why didn't you change the childhood centres to 1500 as well? And I guess the answer is fairly simple. The accident that occurred in Canberra quite a few years ago that caused all of this business of schools having to upgrade their glazing, and most schools introduced programs that businesses like O'Brien Glass have done very well out of, going around auditing the building, assessing their glass and then bringing it up to the standard. And they brought their glass within a metre of the floor. in safety glass. So it was felt that if you suddenly turned around and made it 1500, it'd be a case of, well, you've done well there, guys, let's go for 1500 now. It'd be pretty tough. So I think it'll stay at a metre for quite a while. What I said earlier about mirrors in bathrooms, that also applies to any other mirrors. And if we can have a look at the next slide, just picked out one example there. And as you're aware, if you've got glass in a window and it's within 500 millimetres of the floor of a residential building, it has to be comply with certain thickness and safety requirements. Now in this case, we've got mirror inside a building, it's within 500 of the floor, so that would have to comply with that as well. It's treated no differently to a window. So what the clause is saying is that if you've got mirror in an application where if it was a window, there would be a particular requirement, well, the same would apply to a mirror. I sometimes think there's some buildings where probably it's more critical. If ever you're in Melbourne, if you go into David Jones' store in the city, all of the columns are encased in mirror there, and by gee, you can almost get lost, and if you don't bump into a column at some stage, you'll be doing well. Stairway glazing was a new addition to the standard, and simply required that if you had any glass within 2 metres of the bottom riser in a line straight ahead of you, that glass had to be safety glass. And if there was any within a metre either side of the stairs, again on the assumption that you can't fall as far sideways as you might if you trip, that's also required to be safety glass. The standard was a bit slow there. Most window manufacturers had already introduced that long before the standard called it up. Just touching on balustrades, and as I mentioned before, the entire section on balustrade is being rewritten, but the key, it's only being rewritten to try and overcome the difficulty some people have had in understanding it. Certainly there's going to be a lot more tables, a lot more diagrams, but the key change that occurred 2 years ago won't change. In that we now really have 2 types of balustrade. You have structural balustrade panels where there's a handrail, it's supported by the structural elements and thus is capable of safely resisting the loads, or infill balustrade panels. So if you look at the slide showing a photograph of a typical balustrade there, and that's pretty common. You've seen miles of those around the cities. Well, the ruling now is that if that balustrade is protecting a drop of more than a metre, you can't do that. So that would be out in that application. That would have to have a handrail. So it'd look like the next slide, which shows, again, that sort of balustrade. And that one's really describing all types of balustrade where it's protecting a difference in level of a metre or more, and it must have a handrail that is capable of supporting the loads. One type of handrail that's referred to probably excessively as an interlinking handrail, and that's one that has to, where you've got at least 3 panels, it spans the 3 panels, and it must be, while it's called non-load supporting, it actually has to support the loads or be capable of supporting them if one glass panel fails. And the final point on, or the 2 final ones, firstly, one of the tricky parts with balustrades is, and these tables that have been included in the standard show the loads, but how do you decide on the load that you're going to apply to read the table? And one of the things I always tell anybody in the industry is don't attempt it. Get an engineer or the owner of the building or somebody else to decide, you know, what is the load it has to withstand, because if you go to AS 1170, the loading code, it has a table in there that shows various loads, and it would start with a simple residential application going right through to football stadiums and areas where there could be panic in the area or there could be a lot of pressure put on it. And I think the average person that does balustrades, of which there's an awful lot of them around, would have no idea really what the eventual usage of that building is, and it really needs somebody that knows what they're doing to be able to read AS 1170 and look at those loads which are in the tables and in the glass code and determine which ones are appropriate. So we're certainly putting in more of that out of 1170 into the revised standard, and it should help, but I think we'll have quite a few precautionary notes in there. The next slide is actually just an example of one of the tables that are in there, and I'm making the point, it's not the responsibility of the glass installer or the glass supplier to work it out, but if you look at those design loads in the left-hand column, somebody has to make a choice. And there's, I think there's currently 6 tables in the glass standard, and the new one there'll probably be 9, but somebody has to read that and make a call. One of the other tables even goes to the extent of having loads that are in kilopascals, and I've known some people in fairly responsible positions to say, oh well, that's wind pressure because it's kilopascals. Well, it's not, it's still a people type load. So I think it's fairly frightening, some of the things that are being done. The only difference is they've got something to work from now. In the past there was nothing in the glazing standards to help them out. So they're the main things that have occurred with the standard. As I said, there are changes going on at the present time. You might be aware you can't use 3mm glass in an area any greater than 0.85 of a square metre. There is a move to eliminate 3mm glass altogether. There's one very, very small part of the industry doesn't like that, so we've got a problem there to get around that one. And hopefully that will make next year's BCA. So I'll move on quickly and talk a little bit about glazing and energy efficiency, and that really is a huge subject now. Little house that's shown there perhaps gives an indication of what goes on and the impact of glazing, because if you look at that that's actually about a 22 square house, probably a reasonably average mixture of glass in it. It's probably got about 40 to 45 square metres of glazing in it, and the glass only accounts for 8% of the total building envelope, whereas the ceiling is 36%, the walls are 20%, and the floor is 36%. Yet if we look at solar heat gain, that's heat shining straight on the building, the glazing actually accounts for 91% of heat gain, while the others are considerably less. And we're talking about July here, if we go to the next one, which talks about or shows heat lost through the building envelope, the glazing accounts for 60%. So in the glazing industry, of course, and when I use the term glazing, what I'm talking about, as does the building code and all of the software for rating houses, glazing now is interpreted to mean the glass and the surrounding window frame. So when you see performance figures, and we put them out of how glass performs, but at the end of the day you have to look at how a finished window performs, taking into account what type of frame that it's in. So it's pretty obvious that the first thing any building has to have fixed, of course, is the insulation, but I think with those percentages you'd have to agree that that glass is next. But that's been quite a battle with, in some quarters. We fought the Building Codes Board for a long time. One of the people on the Building Codes Board actually referred to windows as an unfortunate hole punched in the insulation of the building. And it's taken a long time to change his view, but it has been changed, and he actually speaks to functions in the glass industry these days, so that's a fair sort of victory. But that was just really that old attitude of thinking that glass and window frames were just that same one that's been around for so long, bit of clear glass in a pretty basic aluminium frame. And it does perform badly. There's no disputing that fact. What you would see if you pick up that book that I'm leaving here for you tonight is the enormous range of glass products that are about now. Yet it takes a long time to get the message through. I picked up a magazine the other day that's being sold, very glossy magazine. The lady wrote a 3-page article on energy efficiency, and when she got to the windows, she said, well, you can get a lot of heat in the west side, so you want to have your windows as small as you can and as few as you can. You can also get a lot of heat in the morning that'll make your house very hot, so keep your windows as small and as few as you can. And the south never gets much sun, so you're going to get heat loss there, so keep the windows as small and few as you can. And of course you turn the pages of the magazine over from there, which happened to be in the middle of all the building designers awards, and every glass must have been averaging 75% glass. So we felt she was a little bit behind the times. But that attitude still exists there, but it's slowly changing. The big benefit, of course, of getting we would see the right type of glazing as being part of a passive design. We all want to keep down the amount of money that's spent on heating and cooling appliances. And if you take the house that's on the next slide, it was done up in Newcastle by a builder, Bernie Hockings, where you've got two houses there, an existing 1-star home, and beside it's a new 7-star home. And I appreciate in New South Wales that you don't talk stars, because you're still, that dreadful thing called basics operates up here. But basics, I think, is sitting at around about 3.5 to 4 stars. In this one, the 1-star home required a 16,021 kilowatt air conditioning system to achieve comparable comfort to the new home that have been designed and built for good passive thermal performance. And of course, once you finish the house, you then have to run that. And the way we're heading, of course, that's a big item. So good element of any good passive thermal design is the selection of energy efficient glazing, because we've got to look to get that free solar heat from the sun during winter months, solar control minimising heat gain through the west and east. And to do those things, it's a balancing act. I've worked in the window industry for a long time. I've got to tell you, getting window reps especially to understand that the real solution is not one type of window on 4 elevations. That's really unnecessary. If you get the best window there, you're wasting money. You can, balance. There's products that vary right around the house. We can minimise heat loss from the inside to the outside, minimise heat transfer from a warm outside air to a cool interior, and reduce the reliance on ideal orientation, which invariably is pretty difficult to achieve in any case. One of the important little charts that we use is that one, and we use that in both residential and commercial building, because we've found over the years that no matter what you do, the total cost of mechanical equipment and glazing will add up to the same figure. It's about $300 we work on. And if you look out at the left-hand end, you've got a situation there with some clear glass in a window, which we're saying is about $50 a square metre. Up the top, we've got the heating and ventilation and air conditioning, $250. And as we put in better glasses, and I've just picked out 4 then, Super Green, you might have heard of a product called Evergreen, now called Super Green. That's a better glass. We go to a heat reflecting glass, right up to an insulating glass unit or a double glazed unit. And no matter what you do, it'll finish up adding up to about that same figure per square metre. But of course, when you finish the job, the heaters and the air conditioners keep charging, whereas the passive design doesn't. So I've already mentioned the building code, if we look at it, refers to glazing as a transparent or a translucent element in its supporting frame, so that's important, in the external fabric of the building, and includes a window other than a roof light. So in looking at that window, we've got to consider the frame type, whether it's aluminium or timber, it's got a thermal break, what the solar heat gain coefficient is, what the U value is. And I've added in another one there, and that is the visible light transmission. One of the things I've found over the years, and especially for some strange reasons, Queensland and Tasmania, they love grey glass. And regardless of what the climate is, they put it in. And because they like the colour. But invariably, you'll hear complaints later, they're disappointed because when they go into the house, it's quite dull inside. And I always figure, and I tell all of our people, tell them about those two previous things. Sure, how much heat a glass will let through and how much it'll let out, but also tell them what is the daylight transmission. And they should appreciate you can get very good performing glass that'll let through more than 80% of daylight, and you can get glasses that will only let through 10%. And whoever's putting it in needs to be aware that that range of options is available. Whether you're aware of these terms, I've no idea, but these of course are the terms used in the building code, and all of the software falls back on them. All of the glass industry and the window industry have had to fall back on these or comply with these. And you've got the two measures. One is U value, and U value simply measures the insulation ability. You're familiar probably with R value. U value is simply the inverse of R value. The lower the U value, the better the insulation. Solar heat gain coefficient, it measures heat gain. It only counts when sun is shining on the window. For instance, if you've got windows on the south wall, the sun probably doesn't ever get to it, and so the solar heat gain coefficient is it means nothing there. and visible daylight transmission, all the data you'll see will tell you what percentage is allowed through. I'll just run through a very short list of a couple of products just to give you an idea of the range. I've started off at the top by talking about toned glass, so that's the ones you're probably familiar with as a tinted glass. And if you start the traditional ones, I've referred to them as grey or bronze, they have a solar heat gain coefficient of 0.64, which means that compared to a clear glass, they do reduce heat gain by around about 25 to 30%. So they're for basic solar control and they won't provide any insulation. They're for reducing the heat coming in from the sun. If you use a green, not everybody likes green, but green has that, it's going to have a similar performance with the heat, but it has the unique ability to let daylight through. So it lets 80% of daylight through. And that's why in your cars, any modern car has green glass in its windscreens. So all they are to me is the first level of solar control, and they don't insulate against heat loss. Then we go down to the ones that I'd call super tones, and the performance there is 0.35 to 0.6, so they're cutting out maybe in the range of 50% of heat gain. Grey, blue, you can see the daylight transmission of that grey, only 17%, whereas blue's 65. Go across to green, it's letting through 73. So terrific for daylight. But there's a big difference in those, but they're providing what I'd call first level or second level of heat reduction, but they don't do anything at all for heat loss. It's going to let the heat go through just the same as a piece of ordinary clear glass. Thermatech's just one of our brand names for double glazing. If you think of a piece of ordinary clear glass, it has a U value of 5.9. If you put in a double glazed unit, depending on what's in it, it can get down as low as 1.5, which you're talking about more than 50% reduction in its insulating ability. 2.7 is what you would get by putting two pieces of clear glass in a double glazed unit. If you put an argon gas in that space, it comes down to 1.9, and if we put a low emissivity glass in it as well, you're getting to a pretty fancy window, but you're down to 1.5. And of course you can get a wide variety, you can put anything, any type of glass into them. But low E glass, and I'll tell you a little bit about that in a moment, is without doubt the future of the glass industry. It's certainly taken over overseas, and it's certainly starting to do so here. Low E glass has a special thin metallic oxide or oxide coating. It allows the passage of shortwave energy, and shortwave's what's coming from the sun, into the building, but prevents long wave energy, which is what is generated internally, from getting to the outside. It allows light to come through, most of the light to come through, while it's providing insulation. It can be put into a laminated glass, so you can then get insulation and solar heat gain coefficient down to a low figure as well. So it's where you're getting into this whole thing of combining products where you need a better performance that it's hard to go beyond a double glazed unit. I guess a lot of you would have heard of a product called Comfort Plus, and Comfort Plus was a laminated glass. It does include a low E glass in it, and it's become extraordinarily popular. However, it should be remembered, it's sort of a middle of the range product. It's never going to perform as well as a double glazed unit. And if you look at the three products I've listed there under U value, it has a U value of 3.6, whereas the double glazed unit was down at least to 2.7 and maybe 1.5. So it's a lot better than a piece of clear glass at 5.9, but not as good. But if you take Comfort Plus, and it's a classic case of if you're trying to get one product right around a house, how you have to vary it, because the neutral product, which has a low solar heat gain coefficient, is 0.52, and the bottom one, clear, has a high solar heat gain coefficient. And that's for one reason. That was developed when it was found that when houses were being rated, where Comfort Plus Neutral was put right around the house, they weren't rating all that well. And it was discovered it was because that Comfort Plus Neutral was cutting down the heat on the north wall in the winter months, and the software was looking for free heat. So we had to come up with this clear version that allowed the sun to come through on the north wall. So a good combination then is a mixture of neutral and clear. You might be interested, I've dropped this one, it's out of left field a little bit, but the low E glass, and it shows what's happened in the United States, how it's absolutely taken over. And market penetration, up around the 80-90% now of all windows in Europe now, where in a lot of countries double glazing is mandatory. Many of those have even made low E glass mandatory, and by the end of this year we'll be producing low E glass in Australia, and there'll be no longer any imported glass coming into our company. This rather magnificent looking table up there, and I always dread it when I put this up, but there's a purpose to it. It's an effort to try and make something simple. What it shows, don't worry about all the product names down the bottom, but those first bars that are up very high, they're those tinted glasses and toned glasses, solar control only, and you can see they're showing a very high insulation. So they're not performing in insulating, they're only providing solar control. We come down to the next lot, which is Comfort Plus, which, as I said, is a mid-range performer, and it's providing a medium level of solar control and a medium level of insulation. The next one across is a basic double glazed unit. It's providing high level of insulation. And then if we come across to the last one is where we start adding a low E glass into it, and we're getting right down to 1.9. The point to be remembered, however, is those last two, you could put a solar control glass in those and it would have no adverse effect on the insulation, but you would retain you would then get the benefit of solar control. And the next one, and might as well click on all of those if you would, and it's simply saying, this is where we confuse people, but if you look at the bars that are up high, clear single, clear double glazing with low E, and super green with low E, what it's showing there is that they're performing a function at reducing heat coming in, but again, it relies on the product that it's mixed with when you put it in there. If you come across to that very low one down there in the green over on the right hand side, that's where that super grey has been put in, and of course it gives you very low solar control but very good insulation as well. Bit hard to absorb, I know. Okay, happy to take any questions, but I might just run through these questions that seem to get thrown up a lot and came from building designers. What are the physical and aesthetic ramifications of installing different performance glass types in different orientations? Typical building designer's question, I guess. Physically, most window suites now can accommodate either single glass or double glazing up to 12mm thickness. And timber's been fine for a long time, aluminium's been slower, but mostly they can put that in there. From an appearance point of view, however, solar control glass will vary in colour or tone. A neutral colour solar control glass can be put in with a medium level of solar control like Comfort Plus. It'll appear a little bit different to the clear version, but as long as they're not in windows next to each other, it won't matter. If they're on different elevations, you wouldn't pick it up. But generally, when you get into high performance solar control, you're generally introducing colour. Does one glass suit all situations? Well, the answer really is mostly no. The only answer, the alternative that is, if you put in the very, very best double glazed unit, you could probably say yes, but you'd be throwing money away. That's what it amounts to. In many parts of Australia, there's a need to allow the sun in the winter months, so a high solar heat gain is required, which is usually the north, while the east and west want that low solar heat gain to reduce heat gain. And you may be able to achieve something of a consistent colour if we get into some of these neutrals and clears, but of course one thing needs to be kept in mind on the south is daylight, where it can be a little bit on the dark side. In hot parts of the country, a solar control glass with insulation, you might be able to use that on all elevations, but it really does vary as which zone you're in around the country. What to do if you need different glass types on different elevations within one room? Well, as I've said, I've really answered that already. You can consider products like, we've got a couple, Comfort Save, Comfort Plus, there's another one called E Vantage, which is low E glasses, because they're available in clear and neutral. But they're slightly different nevertheless. They're definitely not identical in appearance. They've got good solar control and give you medium level of insulation. Now that's a mass of numbers, and I'm sure has gone in one ear and out the other. It's usually the case, which is one of the reasons I've brought along that book for you. But firstly, on our website and also in that publication that I'll give you are a lot of tables that show combinations of every glass that you can imagine, and all of the performance figures. But the important ones, and that one I've put up there now just happens to be double glazing with a low E glass. But there's tables there that start with just a basic clear glass, basic tints and so on. And as you probably can see, I think, as you go over to where the three arrows are, the first one is the U value, the second one is the solar heat gain coefficient, and the third one is the daylight transmission. And they're the three critical figures. The rest of the numbers on there wouldn't be very important to you. So you've got the product names down the left-hand side, what the makeup is, and I think you got ahead of me by one slide there. I thought that didn't make much sense. Sorry. So that table there, which just happens to show 4 different glass types in a double glazed unit with a low E. It shows the makeup of the glass in the first column, and then as you go across, that's solar heat gain, daylight and so on. However, generally that's the chart. They're the charts, ours or other glass companies, that are used to sort of decide what is the product I really want to put in. But then when you come to rating a building, that's not sufficient, because you have to take into account the frame. And the only way you can do that at the present time is to go to the next one, which is out of the Window Energy Rating Scheme, WERS as it's generally known, and that's where window manufacturers have had their windows custom rated. So if you were to go into that website that I've put down there, it gives you the window manufacturer by name, and there's something like 3,000 different windows on there now. The type of glass, it starts there with 3mm clear, 5mm clear, and going across again, that's the U value, the solar heat gain and the daylight transmission. If you were to compare it with the glass one, you will tend to find that when it comes to solar heat gain coefficient, you put the glass in a frame, and the figure will improve, because what you've done is reduce the exposed glass area by the frame. With insulation, it'll go the other way, because generally the window frame mostly won't do as well as the glass, with the exception perhaps of timber. Timber will do well, aluminium perhaps not quite so well, but there again, aluminium manufacturers are now developing frames with a thermal break in them that will do the job. So that takes me right through it. Thank you very much for your attention, but if you have any questions, I'd be only too happy to have a go at answering them in any case.
First off, what is a store board?
A store board?
I don't know.
Don't you? Okay, fair enough. It's a board that, or it could be any, not a board, a material. You know, when you look at and perhaps they're not so common now. Think of your old butcher's shop that had bricks coming up with tiles or something like that at the base, then the glazing would start above that. That panel along the bottom's a store board. Okay. But generally today, of course, the glass tends to go right down to ground level.
Thank you.
I think I missed the answer to this question. In retirement villages, why has it got to be 1,500 off the floor for the laminated glass?
Bigger people, I guess, is the simplest answer I can give you. That was the reason. It was, again, there was a view put forward at the time that all glass in those buildings should be safety glass. But it always gets back to this cost factor. When you're trying to put in something into regulations now, it's harder now than it ever was. You do have to put forward a cost-benefit analysis to the Building Codes Board, and you can sort of justify 1,500 because if a person falls, generally they'll be within 1,500. But
Is that like 10 people fall and get killed, then is that the cost benefit, or?
it's not as silly as it sounds, because one of the questions we've often put to the Building Codes Board is, what is a human life worth? And they can't answer it, and they admit it's something that they've talked about a lot, because we mentioned that case of the young boy that was killed in a childcare centre, And we've had other examples, and the building code have come back and said, yes, but it was only one child and it's been thrown back at them. Well, you know, what if it was your grandchild? But so once it comes to that human impact part of the standard, it is extremely difficult. If we're fighting on, say, wind loading and the ability of the glass to resist wind, you can do it. But you can talk about what glass is broken and been analysed, but when it comes to people falling, it gets very difficult.
A lot of the glasses are, the values are pending.
No, that's the. It's not the glass value. It's the rating of the total system.
Oh, right.
That's been done. And what those two columns were, they were on the website up until recent times. And I don't know whether to get into this or not, but previously all performance figures for Windows were done under Australian national average conditions. All of those have had to be re-rated now to NFRC, which is the National Fenestration Rating Council readings, and so it's made it hard for them to talk about what is the improvement. And that's what those columns were for, but it doesn't affect anything.
How do you know what glass you've got? Is there stamps all over it or something?
Oh, that's a woo of a question, that one. It's not. That is, you know, it's very difficult. It is extremely difficult. I've spoken at functions recently with building surveyors, and of course they're criticised. In fact, they're concerned that they're signing off on jobs saying that the glazing is in accordance with AS 1288 and the windows are in accordance with 2047 and the energy efficiency it's been glazed, and they're relying on the certificates that some give them. And I can tell you there's some windows that are coming into the country today, fully glazed from another country, and they do not perform to the window standard or the glass standard or the energy rating. There are ways, but it's quite awkward, and even people that have been in the glass industry all their lives can struggle. There's equipment you can buy these days that will do it. You can get laser equipment that will even go to a piece of laminated glass and it'll tell you what the two thicknesses are and what the interlayer in the middle is, and they're about $600 each, I think, and you need a couple of them. There's another one that can tell you what the coating is on the surface. What we're trying to do is to, and we met actually only last week with the Building Codes Board to try and get it made mandatory that these products be properly labelled, that everybody has to label them. We're part of the way there now. There's a body being formed called the Australian Fenestration Rating Council. You might have heard me mention just before numbers that are National Fenestration Rating Council, which is the American body, but that's a body that determines this sort of information worldwide, and we've set up an affiliate here in Australia so that works to their rules. And one of the first things what it will mean is that you will not be able to get a window rated without it having been carried out by somebody who's been tested and audited by this AFRC. So that's a terrific start. One of the next things we want to do is get this mandatory labelling brought in. Now the Building Codes Board are all for it, the Australian Greenhouse Office is all for it. Some glass is labelled at the moment and a lot isn't, and some is put on labels that tend to get taken off by the window cleaner before anybody gets a proper look at it. So there's more of a debate around that. How can we produce something that will be on there at least for a reasonable period of time until the building is assessed? But once the labels go, then you've got a problem. We have toyed with double glazing. There's been a suggestion that, you know how you have a metal spacer bar between the glass, maybe getting something stamped on that.
I inspect a few buildings, and during inspections, you know, you've got to look at whether, say, on a block of units, the windows are rated, and it's very hard out of the standard to see what are the requirements for, say, a big set of sliding doors on the 10th floor.
Yeah. Well,
you know,
that's right. If they're external, of course.
Yeah.
I mean, the standard doesn't even cover it.
Yeah, well,
I mean,
you know,
the standard only. it's a big question you're asking, because it gets back to wind load. Where did the wind load come from? And generally, if you take wind loads for housing, that only covers buildings up to about 8 metres. 1170, without calculation, only covers up to 10 metres. You're getting up to a height that it needs to be referred to the engineer.
Yeah, but I'm talking about what sort of features does a sliding door of that? I gather that the two mullions, or the two styles on the fixed light and the sliding light interlock to provide a greater strength. But that doesn't really tell me very much at all.
No, it wouldn't. Now there should be, from that window manufacturer, a test certificate to show that that design has been tested.
Right, and where is that supposed to be?
Back with the window manufacturer.
No, but I mean on the window, is it?
It's not.
Oh,
Sorry, no, that's not quite true. It is. Provided it's somebody that's complying with the standard, there should be a label perhaps in the jamb,
all right.
or in the usually in the jamb or the head. You'll see a label that will have a couple of logos on. It'll tell you the water penetration it performs to, the wind pressure, and a couple of other things. And might also have a logo on it to show that it's been energy rated.
Yeah.
Now, all of the members of the Australian Window Association do that, but not everybody's a member of that. But it's one of the conditions of their membership, and all the major window manufacturers and a lot of the minor ones are there. So there should be a label that you can track down in the extrusion, visibly in the extrusion, either in the head or the jamb.
And then you go looking for the one on the glass, which is never there.
Which is never there, yeah. It's been taken off. Well, when it comes to safety glass, we've got a proposal at the moment that it should all be permanently marked. And that's what I think, it should be permanently marked. Not everybody agrees with me. But we're going to fight, we're trying to bring that in. And they talk about, the trouble is it'll get put into the window frame, and instead of being down the bottom right-hand corner, it'll be upside down in the top left-hand corner. All those sort of things get thrown up. People that are production-oriented don't like it. It's a pain in the neck in a factory. But I think if we want compliance to be enforced, it should be visible.
Noel, thanks very kindly.